Okay, hello. So today we're looking at question 2058. Find the minimum and maximum number of nodes between critical points. So how do we define critical points? According to the question, a critical point is either a local maxima or a local minima. So local maximas basically mean that the current node value is strictly greater than the previous and the next node. And local minima means the current node's value is strictly smaller than the previous node and the next node. And note that it has to be like sandwiched between two other nodes for it to be considered a local minima or maxima. Like for example, in example 1, there's only two nodes, right? So there isn't any critical points. There can't be any critical points. So our task here today is, given a linked list head, return an array of length 2 containing minimum distance, and maximum distance. So, like no matter whether it's a local minima critical point or a local maxima critical point, as long as it is a critical point, we can use it to consider our minimum and maximum distance. And if there are fewer than 2 critical points, we're supposed to return -1, -1 as our output. Let's just look at some constraints. Number of nodes in the list is in the range 2 to 10 to the power of 5, and node values ranges from 1 to 10 to the power of 5. Okay, cool. So let us look at an example here. I just kind of copied example 2 over to this whiteboard where I can draw with my stylus. Yeah, so hopefully this will be clearer. Okay, right, let's get started. So in this case, we have 3 critical points. The third node, the third node, the 5th node, and the 6th node. Because if we look at this third node, it's sandwiched between 2 nodes that's strictly larger than it. So it is a local minima, node 5 is a local maxima, and this node 6 is a local minima. So what we return basically is the min distance and then the max distance. So the min distance, as you can see over here, it's just 1, and then the max distance is, it's a very ugly arrow. Let me try again. Why is my, okay, we have 3, 1, 2, 3 edges in between. So we need to initialize a few things. Like we kind of need to declare a few placeholders, right? So the first one is obviously the minimum distance and then the maximum distance. We store it we store the values inside these placeholders so that we can eventually return these values as output. And what else do we need? We can see that we kind of need like a pointer. Can I change the color? Maybe. Yeah, I should. We kind of need a pointer pointing to this node over here, which is our first critical point in this linked list, right? So that we can use for the to figure out like what the max distance is as we traverse down the linked list. And then we also, other than that, need another pointer to kind of like keep track of what's the previous critical point, so that when we are at, like for example in this case, when our current pointer eventually reaches here, we have another pointer pointing to this node so that we are aware that we call it previous critical point, so we're aware that like the distance between these two is what we're going to use for the minimum distance, what we're going to output as the minimum distance. So for example, and I'm not going to fill in the values, but I just want to like illustrate a point. So in this example here, right, imagine if this is the, for example, this is the first critical point, and then let's say this is the second one. Okay, so by the way, I just want to make a note that we don't yet know, right, like if it's a critical point or not until our current pointer kind of like reads it in a sense and like looks at the values, right? So what I'm drawing is basically after the current pointer has moved past these all these values. So let's, for example, previous critical point is here, and for example the current pointer is here. We need these 3 pointers to like help us figure out what the minimum distance and the maximum distances are. I have horrible handwriting. Yeah. Okay, so with these things in mind, I think we can start trying to code. Yes. Okay, so we have a few things that we want to initialize, right? The first one being the max distance and the min distance. I'm gonna initialize it to a value that is very, very large. Oh no, I don't think I can. So that, you know, like we can, at the end we can check if this value has changed or not. If it has not changed, then we know that we should return -1 as our output. Yeah, because we're gonna be overriding these values if we can obtain the like a valid value to override this min dist and max dist. Okay, so what else do we need to initialize? We do need like a previous CP critical point and like a first CP, but then we don't know what values they are, so we will set it to none for now. None. Okay, is that all? Yep, looks like it. So now what we want to do is point current to, I'm gonna initialize it to head.next, because you know, like it can't be the first node anyway, so I'm gonna start checking from the second node onwards. But we can also put like a dummy node before our head, and then yeah, start from there instead. But you know, like I just wanted to do it this way, I suppose. Okay, so we have current. We also need a previous pointer so that as we, because okay, so like at this node number 3, this, let me just draw it out, because at this node we start our current here, right? We have access to the current.next, so we can compare it to this value, but we need another pointer to kind of compare it to the value before. So I'm gonna name this pointer pref for previous, and let's do that. Pref is equal to head. Okay, so while current and current.next, what we want to do is start comparing, right? If current dot value is more than current dot next dot value, and current dot value is more than previous dot value, current dot, so this condition is for the local maxima, right? Or because we don't really care if a maxima is if the critical point is a local maxima or a local minima, like it doesn't really matter to us. As long as it's a critical point, it can be considered for our distance calculations. So, or current value smaller than current dot next dot value, and current, let me do this, okay, and current dot val is smaller than prev dot val. Okay, if this condition happens, then we have met a critical point, right? So what we want to do is to check if it is the first critical point or not. So if not first CP, so not first CP means if like it will only be like not first CP will only be true when first CP is none. So we're gonna set the first CP right now. CP is equals to current index. Wait, I forgot we need to index it. Here. So current index is kind of like the index where our current pointer is pointing at. So first CP is now set to the current index. Okay. Else, so else means first CP was filled, like kind of has a value already, right? Else, okay, it will go into the else condition when first CP has been set and prev CP has been set too, because right after this block we will be setting it to the current index. Okay, no matter like if it's the first CP or not, right? So else mean this is equals to the whichever one's smaller, like the current min this, or minimum distance current index minus prev CP index value. Okay, max dist is maximum of max dist or current index minus first CP's index. Okay, so we have handled what needs to be done when we meet a critical point in our linked list. Okay, then now what we need to do is we gotta remember to increment our current index every time we move our current pointer, and then we need to remember to step our previous index pointers up. So like prev equals current, and then current equals current dot next. Okay. Yeah, I think that's it for the looping part. So once the iterations are done, we will have to check if min distance is a if min dist or max dist are still stuck at their original values. If it is, then we return -1 -1, or else we return our result, right? So min dist, I think we can just check min dist, and right, because like both will have to be set, because it's either both are set or both are not set. It can't be that min dist is set and then max is not, or vice versa, because after the first iteration, after we set the first, for example, the first critical point, we actually set the previous CP as well. So the next time it comes into this, it hits a critical point and it comes into this if condition, we will have the values to write for both min distance and max distance. So yeah, I think we can just check for one. If min dist return -1 -1, else return min dist first, right? I think, yeah, min dist max dist. Okay, I feel like I'm missing something, but I'm not signed in. No, shit. Okay, okay, will I show my password? No, right? Okay, oh no, oh. Heck, I don't remember my password. Oh no. Okay, perfect. I can't remember my password. Let's try this. Oh, I should have clicked that. I'm sorry if that was very long. Oh, I've done this question before. 3 weeks ago. 3 weeks ago. Oh, okay, but I don't think I submitted it previously. So yeah, that's it for today's video. Thank you.